मैसेज मैंने कर दिया था, जो भी कर देगी। वी आर लाइव, वी आर लाइव।
Hello guys, my name is Akanksha Sharma. I am from P.R.S Educational Trust. Very good afternoon to all of you who are joining us today for the fourth webinar. If I am audible, please comment yes in the comment section, please. Fast. Okay, so I am going to start. फर्स्ट ऑफ ऑल आप लोगों के सपोर्ट के लिए थैंक यू सो मच और विश यू ऑल वेरी हैप्पी न्यू ईयर एंड मैं जो हमारा आज का टाइटल है वो है डिजाइन ऑफ एक्सपेरिमेंट सेंट्रल कंपोजिट डिजाइन। इसी पे हमारा आज का जो वेबिनार है वो बेस्ड है और जो हमारी स्पीकर है वो है हमारी डॉक्टर श्वेता मैम, जिन्हें मैं इंट्रोड्यूस करने जा रही हूँ। आवर स्टीम्ड स्पीकर फॉर दिस इवेंट इज डॉक्टर श्वेता शर्मा, Professor at Department of Pharmacy, School of Medical and Allied Sciences, Galgotias University. She has published articles in many peer-reviewed Scopus SCI Index national and international journals. She has published 2 books as a chief editor and also has 3 patents published and 8 granted. Ma'am has 16 plus experience in the academics, and we are highly obliged to have a ma'am on our platform. I am handing over the screen to ma'am so everyone can join the webinar and have a fruitful knowledge with this webinar. Thank you so much. I am handing over towards the ma'am.
Very good morning to all of you who have joined this webinar today. I'm going to deliver my webinar on design of experiment, which is central composite design. So, am I audible to everyone? Okay, so let's start with my presentation. So, design of experiment, what is this? As we know that in when we go for the formulation of a dosage form, then we have to go for a number of trials, right? And it is this process become very much tedious. So that to make it convenient as well as to reduce the number of trials, we have to adopt the optimization techniques, and one of this is design of experiment. So here we can go for the number of trials on a software, and then based on that we got the experiment trials, and that experiment trials are performed in the lab, and that results are again input into this software, and then with the help of the statistical analysis done by this, the results are interpreted. So it is nothing but the basic optimization tool. सो ऑप्टिमाइजेशन का मतलब क्या है? ऑप्टिमाइजेशन का मतलब है कि टू मेक परफेक्ट, राइट? सो दैट ऑप्टिमाइजेशन कैन बी डन विद द हेल्प ऑफ दिस डिजाइन ऑफ एक्सपेरिमेंट. सो इसकी हेल्प से हम लोग प्लान कर सकते हैं, कंडक्ट कर सकते हैं, एनालाइज कर सकते हैं, इंटरप्रेट कर सकते हैं अपने रिजल्ट्स को, टू मेक ए बेटर डोजेस फॉर्म which is considered as an ideal dosage form in our terms, right? But one more thing that should be keep in mind, that this the results of this that coming after this experimentation, they should comply with the given standards, because as we know we cannot go beyond the standards, right? So that's why this design of experiment, it help us to make the formulation that is desirable. And one more thing, it gives us the flexibility to choose the independent variables, and the dependent variables we can select out on the basis that what are the factors that are more affected by the effect of the independent variables. Okay, so इसकी हेल्प से हम प्लान कर सकते हैं एक डिज़ाइन को, देन हम उसको कंडक्ट कर सकते हैं, देन रिजल्ट्स को एनालाइज करके हम इंटरप्रेट कर सकते हैं कि वट एवर डिज़ाइन जो हमने डिज़ाइन आउट किया है वो हमारे रिजल्ट्स को वैल्यूएबल रिजल्ट्स आ रहे हैं या नहीं आ रहे हैं। तो उस डिज़ाइन को सेलेक्ट आउट करने में, उस डिज़ाइन को कैरी आउट करने में ये ऑप्टिमाइजेशन टूल हमें हेल्प करता है. So, this method is used to determine the relation between the factors affecting a process and the outcome of that process. So, फैक्टर, टू टाइप्स ऑफ फैक्टर वी आर हैविंग हियर. हमारे पास दो तरह के फैक्टर्स होते हैं. वन इज योर इंडिपेंडेंट फैक्टर. सो इंडिपेंडेंट फैक्टर्स वो फैक्टर्स होते हैं दैट आर इन विद द फॉर्मुलेटर. मीन्स इफ आई एम गोइंग टू फॉर्मुलेट a dosage form, then I can select out that factor. So when I'm going to select that factor, then one that should be intellectually selected, because if I talk about the example of a tablet dosage form, right? So tablet dosage form, it is a basic dosage form that we formulate in a lab. And if I talk about the factors that will affect the quality of the dosage form, tablet dosage form will be our concentration of binding agent as well as concentration of disintegrating agent, right? Because these two factors are the main factors that can affect the quality of the tablet dosage form. While if I will think about it that I should select out the organoleptic properties, it should be good, so I should select out the coloring agent as well as flavoring agent. Okay, so that factors are not which are going to affect adversely the quality of the product. Because when we talk about the filing of the product for getting the approval from the regulatory body, then the product should have the good quality, right? Otherwise we cannot proceed further with the quality assurance. Okay, so I means this is not the task with me that I have to formulate a dosage form, but it should be the quality product, and it should get approval as soon as possible. Because every businessman who is in the association with the manufacturing of dosage form, they have one criteria with them, that it should getting approval very soon, and they can sell their product in the market as soon as possible, right? So it depends on that the product should be of quality. After that only they will be able to proceed it further for the filing of the for NDA, right? And it sale into the market. So here to make that dosage form within a stipulated time period, so that our product will be in the market on the stipulated time period, this design of experiment is used. So when I am talking about the research, then again while choosing the desired dosage form, that can be further utilized for in vivo studies, as well as it can go for commercialization, we should need an optimization tool that help us to make a convenient and appropriate dosage form that can be further analyzed, right? So इस इन सब के लिए, आपके रिसर्च के लिए और आपके प्रायर अप्रूवल, और आई शुड से दैट कि ऑन टाइम अप्रूवल के लिए ये ऑप्टिमाइजेशन टूल हमें हेल्प करता है कि हम अपने फॉर्मुलेशन को उसके फॉर्मूले को ऑप्टिमाइज कर सके किसी एक ऑप्टिमाइज टूल की हेल्प से, राइट? सो हियर हम यहाँ पे क्या देखते हैं कि आपके जो इंडिपेंडेंट वेरिएबल्स हैं, इंडिपेंडेंट वेरिएबल्स में मैं ये कह सकती हूँ कि आपका बाइंडिंग एजेंट की कंसंट्रेशन, आपके डिसइंटीग्रेटिंग एजेंट की कंसंट्रेशन जाके इफेक्ट करेंगे उस टैबलेट के हार्डनेस को, उस टैबलेट की फ्राइबिलिटी को, उस टैबलेट की disintegration time को and dissolution time को, right? So the while selecting the independent variables, one must be sure, you have to ensure yourself that these factors should be selected on the basis of a strong objective. So here strong objective is the product should be of quality type. right? And so relationship between factors affecting a process, so these factors are going to affect the disintegration time, these factors are going to affect the dissolution time, these factors are going to affect the hardness and or friability of the tablet and outcome of that process. So outcome is what? Outcome is the quality product. So whatever we are doing, it should be in a manner that the quality should not be hampered of the product. This is the main criteria. Second criteria is, when I am going to select out the independent parameters, these should be that parameter which are directly or indirectly related to the quality of the product. So, as I told you earlier that about the factors, so these factors may be quantitative or may be qualitative, right? If we see the dashboard of the factorial design, that design expert, two types of factor it shows over there. One is your numerical factor and second is your category factor. So if I talk about the numerical factor, then it is the quantitative factor, right? Here we can take out the concentration, either 1 2 3, where I am talking about the numerical. Okay, ये numerical भी हो सकता है, category भी हो सकता है. तो जब मैं न्यूमेरिकल की बात कर रही हूँ तो वो कंसंट्रेशन हो सकता है, अमाउंट हो सकता है, क्वांटिटी हो सकता है, जहां पे हम मेंशन कर रहे हैं उसकी पर्टिकुलर क्वांटिटी. दूसरा फैक्टर कैटेगरी फैक्टर हो सकता है, वेयर आई एम टॉकिंग अबाउट द ग्रेड ऑफ ए पॉलीमर और ग्रेड ऑफ एनी अदर एक्सिपिएंट, राइट? हियर humidity condition we can take. So this is the qualitative factors. If I am going to study the effect of a categorical factor, then I will select out the polymer grade. That's, yes, this grade, for example, we can take the grade of HPMC, right? You all have heard about the HPMC. So it is available in 4K, it is available in 15K, it is available in 100K. So according to its this concentration or its grade, the molecular weight of HPMC increases, and then according to its grade, the gelling capacity of the HPMC also changes. So if I'm selecting the category, then I will see the effect of the grade on our dependent parameters. So next is your levels. So levels we have to set out at 2 level we want to see, at 3 level we want to see. So how in means here in factorial design we can take two levels, where either I will check it out at low level as well as I can check it out at high level, right? So दो level भी हम ले सकते हैं, and we can select out 3 levels. हम 3 levels भी select out कर सकते हैं. 3 level में 3 levels means low, medium and high. So that factor is studied at 3 levels, means the minor concentration of that factor, the medium concentration of that factor and highest concentration of that factor, how it will be going to affect, right? So if I am keeping it at minimum level, then is there any response, is there any effect on the response? When I am taking it at the medium level, any response is there, it should be definitely better than the lowest level. And if I will keep it at the highest level, then what type of response will come? So at 3 levels I can check out the effect of the independent variable on the dependent one. So now next is response. So response is what outcome is coming of the experiment, right? So here we can say that these responses are the dependent variables, on which variable I want to see the effect of the independent factors. So independent factors are in the wish of the formulator, they are in the hand of the formulator. फॉर्मूलेटर इंडिपेंडेंट फैक्टर्स को सेलेक्ट आउट कर सकता है, और आपका जो डिपेंडेंट फैक्टर है वो फैक्टर्स होंगे जो कि डायरेक्टली इंडिपेंडेंट फैक्टर से अफेक्टेड होंगे. फॉर एग्जांपल वी कैन टेक इट दैट डिसइंटीग्रेशन टाइम. सो अमाउंट ऑफ डिसइंटीग्रेटिंग एजेंट in the formulation will directly affect the disintegration time. If I'm going to formulating a floating doses form, then the duration of buoyancy means for how long the tablet is floatable. It is on the surface of the gastric fluid. That duration I can check it out. So again, it depends on the amount of polymer which will give the flexibility to tablet to float, will affect this duration of buoyancy, right? Then thickness, I can check it out. So what thickness I am selecting out while punching, it affect the thickness of the tablet, right? So it is the outcome. So it is a response, you can call it as dependent factor, which is solely dependent on the independent factor. So one thing that should be keep in mind, that the independent factor, as we do changes in the independent factor, the dependent factor will change. There is an effect on the dependent factor. Then response surface, so it represents the relationship between the independent variables, which x1 x2 here representing two independent variables, one is x1 and one is x2, and dependent variable is denoted by the y symbol, right? So this response surface is telling about the effect of these variables on the dependent variable. इन दोनों factors का इंडिविजुअली एंड कंबाइन स्टेट में डिपेंडेंट वेरिएबल पे क्या इफेक्ट आएगा, ये रिफ्लेक्ट होता है रिस्पॉन्स सरफेस से. देन रन और ट्रायल्स. Yes, experiment conducted according to selected experimental design. So it depends on us how many trials we want to run. If we see that more runs are required for a particular process, for an experiment, then we will increase the number of runs. And if I talk about the basic design of CCD, central composite design, which we are discussing today, minimum number of trials or runs are 9. Then we can proceed further to 13 or more than that. So according to our desirability, according to the requirement of the experiment, these runs or these trials are selected, right? So I think I am clear on this point. So firstly, what you have to do, you have to select out an objective, right? What you want to do. Second, on that objective, now you have to select out what factors you have to take. So firstly, you will select out the independent factor. Secondly, you will select out the dependent factor. Third thing is, you will select out the numeric factor you have to take or categorical factor you have to take, right? Then after that, we will check out, yes, at 2 level it should be checked out, or at 3 level it should be checked out. Then responses, we will see, yes, in responses we will see what dependent factor we have to select out. Then in response surface, we will have the surface diagrams which reflect the response of response diagram, where we can see the effect of independent variables or factors on the dependent one. Run or trial depend on how many trials which are required for conducting that experiment. Now, so key steps are, as I told you just now, are these. First is setting solid objective. So your objective must be solid. Yes, what you want to study, why you want this optimization tool, what type of response you want from this optimization tool. Then selection of process variable, factors and responses. One more thing I want to tell out here, that selection of the variables, two types of variables we are having, right? One is formulation variables and second is process variables. If I talk about the formulation variables, then I will select out the amount of excipient, amount of polymer, amount of disintegrating agent. If I am telling about the process variables, then these process variables are stirring speed, shearing speed, or where I am selecting any process variable. Okay, so the independent variables are of two types. One is your formulation variables and second is your process variables. And then responses, what type of responses we want to select out, or what are the responses on which I want to see the effect of these independent variables. So जब मैं वेरिएबल्स इंडिपेंडेंट वेरिएबल्स को सेलेक्ट कर रही हूं तो मेरे पास दो ऑप्शंस हैं. एक ऑप्शन है आपका फॉर्मुलेशन वेरिएबल्स का और एक ऑप्शन है आपके पास प्रोसेस वेरिएबल्स का. अगर आप किसी एक्सीपिएंट की कंसंट्रेशन, किसी पॉलीमर की कंसंट्रेशन, किसी डिसइंटीग्रेशन ग्रेटिंग एजेंट की कंसंट्रेशन, एज वी यूज सुपर डिसइंटीग्रेंट्स, उनकी कंसंट्रेशन अगर आप ले रहे हैं तो वो आपके फॉर्मुलेशन फैक्टर होंगे. और अगर आप कोई प्रोसेस ले रहे हैं, आप शेयरिंग स्पीड ले रहे हैं, आप स्टीयरिंग स्पीड ले रहे हैं, या कोई और प्रोसेस का पार्ट ले रहे हैं जो कि फॉर्मुलेशन में हेल्प कर रहा है, तो वो आपके प्रोसेस वेरिएबल्स हो गए. ठीक है. देन इफेक्ट ऑफ these independent variables will affect which type of responses that are selected here. अब CQA क्या है? CQA है critical quality attributes. So critical quality attributes means वो attributes जो कि उस प्रोसेस को, उस फॉर्मुलेशन को क्रिटिकली अफेक्ट कर सकते हैं, तो वो रिस्पॉन्सेज हम लेंगे. जैसे कि अगर हम ये सोच रहे हैं कि हम ये चेक करें कि टैबलेट ऊपर से दिखने में कैसी है, ठीक है, it should be good, right? It should be uniform because today we have the face value. जैसा आपको दिखता है वैसा वो बिकता है. तो लेकिन हमारा क्राइटेरिया सिर्फ वहां तक सीमित नहीं है, हम लोगों को उसकी क्वालिटी चेक करनी है. बिकॉज हम जो फॉर्मुलेशन बना रहे हैं वो इसलिए बना रहे हैं कि पर्टिकुलर डिजीज के ट्रीटमेंट के लिए वो इफेक्टिव फॉर्मुलेशन हो. राइट. सो यहाँ पे इंस्टेड कि मैं ये चेक करूं कि हाँ अगर ऊपर से दिखने में टैबलेट बहुत सुंदर है, देन आई शुड नॉट गो फॉर इट्स इवैल्यूएशन. नो, दिस इज रॉन्ग. मुझे ये चेकआउट करना है, इट शुड बी गुड फ्रॉम आउटर साइड एज वेल एज इट शुड शो इट्स प्रॉपर्टी. इसकी प्रॉपर्टी क्या है? फार्माकोलॉजिकल एक्शन. सो एज ए फार्मास्यूटिक्स पर्सन मेरा ये एम होगा कि मेरी फॉर्मुलेशन अपने पर्टिकुलर टाइम पीरियड पे, जिस टाइम पीरियड पे ड्रग का रिलीज होना चाहिए फॉर्मुलेशन से, वो उसी एप्रोप्रिएट टाइम पे उसका रिलीज हो. Whatever time a tablet is taking to getting disintegrating in the particular fluid, it should follow that one. Right? It should give the release at a particular time period which is fixed one. So ये क्वालिटी एट्रीब्यूट्स हैं जो कि उस पर्टिकुलर फॉर्मुलेशन की क्वालिटी को बताते हैं. तो ये जो क्रिटिकल क्वालिटी एट्रीब्यूट्स हैं, दे शुड नॉट बी चेंज्ड. So they should be select out properly. Yes, if I will optimize this parameter, optimize this factor, then this parameter will be affected by change of this factor. Right? So if I will say that the main criteria of all this process of this factorial design or using an optimization tool is this step where I am selecting out the independent variables and dependent variables. Right? One more thing is there, that is CPP. CPP is critical process parameters. So when I am selecting a process as independent factor, then what process will be affected by this? If I am changing the RPM, then it will affect the dissolution rate. Right? So according to that, according to our requirement, these factors should be selected. Yes, then selection of an experimental design. So what type of experimental design I should select out? Either I will go for full factorial, either I will go for fractional factorial, where I will see the effect, means various concentration I am using to see its effect, right? So what I am going to select, if it is a, because this central composite design is the basic design of factorial design, right? So should I select this, or should I go for box Venkan? So as per my requirement, I will select out the experimental design. Okay. Then next step is execution of the design. Now I have selected my independent parameters. I have chosen the dependent parameters. I have selected the design. Then what I will do, I will design the number of trials. Then checking that the data are consistent with the experimental assumptions. So experimental assumptions, so here means what I am thinking, if I will increase the this binding agent concentration in the formulation, then its hardness will be affected, right? As well as its friability will be affected. So if more binder is there, then the tablet will be more hard, as well as it will be less friable. Okay, so I have to check it out. Yes, experimentally what assumptions I am having, are these assumptions are as such implemented in the design or not, right? The result should not be like that. If I am increasing the hardness concentration, then the tablet become more friable. No, because as we have studied in the theory, that if hardness means hardness will be increased, if the binding agent will be more, the tablet become more hard. So same consistency should be there here also. So that's why what parameter I am selecting, right? It should be consistent, and what experimentally I am performing in the lab, the software should be consistent with that also, that assumptions. Okay, then analyzing the results. So in this factorial design, it uses ANOVA for producing the results, right? So I have to analyze the results, that these results are up to the mark or not, then use an interpretation of the results. So what interpretation I am getting from it? So for example, if I will increase the binding agent in the formulation, then it have positive effect on the hardness, right? But it is having the negative effect on the disintegration time. Are you getting it or not? It is having negative effect on disintegration time, because if the binder will increase, then the tablet will take more time to disintegrate, while its hardness will be good. So two types of responses we can see. One is positive response and other is negative response. So positive response is on hardness, negative response is on DT. So that interpretation of the result, it should be appropriate, right? So what I am thinking, what I have assumption in my mind, then the result should be complying with that assumptions. If your assumption is not appropriate, your objective is not clear, then you will not get the appropriate results from it. So firstly, आपको अपना ऑब्जेक्टिव सेट आउट करना है कि आपको आप क्या करने जा रहे हो. सेकेंडली, आपके जो वेरिएबल्स हैं वो अप्रोप्रिएट होने चाहिए. आपका सिलेक्शन आपके प्रोडक्ट की क्वालिटी को ध्यान में रखते हुए होना चाहिए. आप देन आपको सिलेक्ट आउट करना है कि आपको बेसिक डिजाइन लेना है, एडवांस डिजाइन लेना है, नंबर ऑफ ट्रायल्स कम रखने हैं, नंबर ऑफ ट्रायल्स ज्यादा रखने हैं. अगर मेरे पास बहुत सारे फैक्टर्स है, इफ आई वांट टू टेक 4 फैक्टर्स 5 फैक्टर्स, देन मैं नंबर ऑफ ट्रायल्स ज्यादा रखूंगी, क्योंकि कम नंबर ऑफ ट्रायल्स में मैं उस रिस्पॉन्स को के माइन्यूट चेंजेस जो उन फैक्टर्स की वजह से आ रहे हैं उनको मैं एनालाइज नहीं कर पाऊंगी। तो अगर आपका बेसिक डिजाइन है, अगर आपके फैक्टर्स कम हैं और आपके लेवल्स भी आप 2 लेवल पे चेकआउट कर रहे हो, तो आपके मिनिमम नंबर ऑफ ट्रायल्स आर सफिशिएंट, काफी है। लेकिन अगर आप एक कॉम्प्लेक्स प्रोसेस को लेकर चल रहे हो जहां पे आपके फैक्टर्स बहुत ज़्यादा हैं, आपके रिस्पॉन्सेज ज़्यादा हैं, तो उस केस में आपको अपने नंबर ऑफ ट्रायल्स को, नंबर ऑफ रन को इंक्रीज करना बेहतर रहेगा, ताकि आप उनको माइन्यूट कंसंट्रेशन पे जो चेंजेस आ रहे हैं फैक्टर्स में, वो आप एनालाइज कर सको और आप उनको इंटरप्रेट कर सको। देन आपको ये चेकआउट करना है कि एक्सपेरिमेंटली जो हम परफॉर्म कर रहे हैं स्टैटिस्टिकली भी उसी तरीके से चेंजेस आए। उसके बाद जो हमें क्योंकि ये किस तरीके से काम करता है कि फर्स्टली हमने एक डाटा सेट आउट किया, देन उसके अकॉर्डिंग इसने हमें नंबर ऑफ ट्रायल्स दिए। नंबर ऑफ ट्रायल्स देने के बाद हम उन ट्रायल्स को लैब में परफॉर्म करेंगे और हम रिस्पॉन्सेस को चेकआउट करेंगे कि क्या रिस्पॉन्सेस हैं। उन रिस्पॉन्सेस को चेकआउट करने के बाद हम एनालाइज करेंगे रिजल्ट्स को। तो हम जो भी उसमें रिस्पॉन्सेस को इनपुट कर रहे हैं उसी को एनालाइज करके ये हमें रिजल्ट्स दे रहा है। So there should be consistency with the experimental assumptions and the statistical analysis. अगर आपका experimental assumptions और statistical analysis comply करता है, then you are getting the desired result. Otherwise, you will be confused in that and you will not get the appropriate results. Is it clear? So now, so that come to the factorial design. So what it does, it allows the effect of several factors and even interaction between them. So by using this statistical tool, what we can do, we can see the responses of individual factors. Many factors we can take, as I told you, we can take 2 factors, we can take 3 or more than that, and it depends on our experimental conditions. So the effect of all these factors individually as well as when these factors are interacting with each other, that responses, this can be seen, effect of individual factor as well as effect of the interacted, when they are interacting with each other, that effect we can see with the help of this factorial design, right? And then to be determined with the same number of trials as are necessary to determine any one of the effect by itself with the same degree. So at a particular degree, what if this is the response, then what effect the individual factor is showing on it and what effect combinedly they are showing on it, on this response, we can check it out by using this factorial design, right? So we can go for various variations, we can do various variations in this, and our aim is to select out the optimized independent factor, right, whose response is the desirable response. ठीक है, हम क्या करना चाह रहे हैं कि इसको यूज करके हम अपने फॉर्मुलेशन फैक्टर को, प्रोसेस फैक्टर को, जो कि हमारे इंडिपेंडेंट फैक्टर हैं, उनकी कंसंट्रेशन और उनकी स्पीड या और जो फैक्टर उससे रिलेटेड है उसको ऑप्टिमाइज कर सके, ताकि जो रिस्पॉन्सेज आ रहे हैं वो हमारी डिजायरेबिलिटी के अकॉर्डिंग हो, दैट वी वांट टू चेक आउट, राइट? So this is a very efficient design because we can avoid a number of trials. Means it is not needed that we have to go for 100 times. We are performing the same experimentation to see the effect of individual variable, and then we are combining these excipients, and then again we are performing the same practical or same experiment. So this can be avoided, and individual effect of the factors as well as combined effect of factor we can see by using this factorial design, right? So finally, these are the only effective way to examine the interaction effect. So as just discussed here, that individual effect as well as interaction effect we can study out by using this factorial design. So by fitting the data into polynomial equation, it help us to optimize the factors. Yes, optimization is to make as perfect. So means choosing the best element from some set of variable, and then we are checking, yes, how we can get an effective formulation. So here what we are doing, we are designing a system, right, where we are optimizing our independent factors, and we are then taking the responses, then we are checking the effect of these independent factors on the dependent one to make a perfect formula, which is called as an optimized formula. So very means various optimization techniques are here: placket Barman design, factorial design, fractional factorial design, response surface methodology, central composite design, and box Bankan design. So today I'm going to discuss central composite design. Later on we will discuss, I will give the webinar on other designs also. So this process is continued. So we will discuss all the optimization techniques one by one. So today we are covering the central composite design, which is the basic design of the factorial design. Yes, this I discussed earlier with you about the variables. So we have two types of variables, which is the means basic prerequisite for any type of optimization technique. One is your independent variables and second is dependent variables. So independent variables may be qualitative, as I told you earlier, may be quantitative. So if it is a qualitative, then type of disintegrant, type of surfactant, type of polymer, grade of surfactant, this can be taken out. Then in quantitative, where we are keeping the quantity of that variable, so concentration of disintegrant or ratio of surfactant, ratio of drug and polymer, ratio of drug and phospholipid, ratio of drug and polymer, right, we can take here as a quantity. Then dependent variables are those variables, as their name is suggesting, these are dependent on the independent one. So independent means they are free, we have our choice to select out the independent variables, and dependent variables will be chosen in like that independent variables, or they both are directly connected to each other. Okay, we will not do like this, that for independent I am selecting now the binding agent, and in response I am selecting out its organoleptic property, because they both are not connected to each other directly. Okay, so if I am selecting the binding agent, if I am selecting the concentration of disintegrating agent, then dependent variable should be the hardness of the tablet as well as disintegration time of the tablet, because these two factors are directly dependent on the independent variables, and they will affect as there will be change in the independent variables. If any one of this is missing, if you are not going to fill this, then you will not get the response, you will not get the perfect design. So if I talk about the process of this experimental design, firstly define problem. So later on I am going to discuss one example with you, where I am taking the example of mouth dissolving tablet, right? So I'm in that example, the drug which is taken out is piroxicam. So this piroxicam, it is class 4 drug, which is having low solubility and low permeability. And this piroxicam drug is used for rheumatoid arthritis, it is an NSAID drug. So in that work, what is done, mouth dissolving tablet of that piroxicam is prepared, because one more issue this drug is having, which is its low solubility, low permeability, as well as its half life is very long. This is 20 hours. So this tablet, this drug cannot be used as a potent analgesic, right? And if I talk about the pain, then you should means you want you want an agent that will affect instantaneously to reduce the pain. So that's why this is the problem statement which is there with this drug. And then second thing is determine objective. So what objective I can take with this drug, that I can enhance its solubility, right? So many ways are there to increase the solubility. Either I go for adding the solubilizer by physical method, by chemical method, I can increase its solubility. Second thing is, as I told you just now, that it is having very long half life, so that its release should be instantaneously. And it, if we are giving it into the oral mucosa, then its absorption will be rapid than its absorption from the GIT. So now my problem is defined out. Yes, this drug is having long half life. Second, it is insoluble or poorly soluble, I must say it is poorly soluble drug. So now I have objective that I can increase its solubility, and second, I can give it in the form of a mouth dissolving tablet, where the drug release is rapid from the formulation and its absorption will be from oral mucosa, so that it will be avoided for going into the GIT. Third thing, now I have to think over it. If I'm going for the optimization process, then what type of parameters, means independent dependent variables, I should select out. Okay, so here I should select out, firstly, if I want the mouth dissolving tablet, then its DT should be very less, means disintegration time should be very less. It should disintegrate within fraction of time into the saliva, so that it can be absorbed rapidly from there. So for this purpose, what I should choose as independent variable, the super disintegrant. So if I will add the super disintegrant in the tablet, it means its disintegration will be rapid, and it will absorb from oral mucosa very rapidly, as it was getting absorbed from GIT very slowly, right? Second, I can select out one more factor as independent factor, is subliming agent. So subliming agent is that agent that give the flexibility to the matrix, so that the tablet will disintegrate rapidly. So both criteria I can met out. Firstly, its rapid disintegration and its rapid release into the saliva. Second thing, now I have to select out the dependent variables. So dependent variables I should check out, select out is, I can select out its hardness, I can select out percent friability, I can select out DT. These three I can take out, because all these three are directly connected to the independent variables, which I have taken as concentration of super disintegrant and concentration of subliming agent. So both factors should be connected to each other. It means if there is any change in the concentration of the independent factor, the dependent factor should change instantaneously by the change in the independent factor. After that, I will design the experiment. I will select out, yes, these factors should be studied out at 3 level, or it should be studied out at 2 level, or more than that. Then I will select out the number of trials, right, number of run which I should keep. Then I will conduct the experiment. So when I will choose the levels, then I will choose the runs, and then it will give me a layout, design layout. So in that design layout, what it will give me, it will give me one x1 means the concentration of first independent variable. Second thing, in second column, it will give me the concentration of second independent variable. Okay, then it will give me two more columns which are blank. One is your dependent factor 1, and second column is dependent factor 2, which I have just selected. Now what I have to do, I have to do that experimentation in the lab. Means I for example, I have selected the 9 trials, which is the basic design. So firstly, I will formulate that 9 designs in the lab, and then I will evaluate that 9 trials for their disintegration time, person friability, and hardness. If I am selecting 3, and if I am selecting 2, then I can take person friability and dt. Okay, then whatever the results I am getting in the lab, when I have performed that experiment, that results are fitted into the response column. So after fitting that, I will finish it, right? Then I can see it will give the evaluation of the responses. Means that evaluation will show the effect of the independent variables individually and combinedly on the responses. Okay, then I will analyze the data. My concentration while analyzing the data will be on the p value. P value is what? It is the variance. Variance means whatever experimentation I have done, that how it is behaving when it is in this statistical tool. So there should be the variance between the responses. The variance should be less. The responses, if it will be more variant than the statistical value, it means the experimentation is not good, right? So how much they are variant from the predicted one. So if what I am predicting, the more variance is there, it means there is an issue with the experimentation. Okay, so it should be less than p less than 0.05, which is taken as a difference between the results. Then, so if one agent is decreasing something, then your treatment should increase that. So this is the variance. Means if I'm taking a stimulating agent which is decreasing, which is causing a disease, then what treatment you are giving, it should increase that response. So this is your analysis of variance. So here also I am studying this. I will study, yes, if the means formulation is giving its appropriate results or not. If I am increasing the binding agent, then in that batch should give more hardness. It should not like that. If I am increasing the hardness in this, if I am increasing the binding agent in this group, then this group is showing the less hardness. So it means the experimental results are not complying with the statistical results. So according to that criteria, yes, if this independent factor will increase, then this should increase or this should decrease. According to that, I will analyze the data. Then I will go for the interpretation of the results, what type of responses I am getting from it. Then I will verify the predicted results, means experimental results are complying with the statistical results or not. I will go for that prediction. So this is the whole process. So firstly, हमारी प्रॉब्लम स्टेटमेंट क्या है वो डिफाइन आउट होनी चाहिए कि आप जो ऑप्टिमाइजेशन प्रोसेस को यूज करने जा की सोच रहे हैं या करना चाहते हैं, उसके पीछे आपकी क्या प्रॉब्लम है, क्योंकि आपकी जो प्रॉब्लम है उसी से आपके ऑब्जेक्टिव डिफाइन होंगे कि यस ये इश्यू है और मैं इसके लिए ये ऑब्जेक्टिव लेकर चल रहा हूं या चल रही हूं कि इसके लिए मुझे ऑप्टिमाइजेशन टूल का यूज करना है। उसके बाद आपको ये सोचना है कि आपके इंडिपेंडेंट वेरिएबल्स और डिपेंडेंट वेरिएबल्स क्या होने चाहिए जो कि उस प्रोडक्ट की क्वालिटी को अफेक्ट करेंगे डायरेक्टली और इनडायरेक्टली। उसके बाद आप उस एक्सपेरिमेंट को डिजाइन आउट करेंगे, कितने नंबर ऑफ रन आपको रखने हैं, कितने नंबर ऑफ ट्रायल आपको रखने हैं, आप वो सेलेक्ट आउट करेंगे। उसके बाद आपके जो मैंने अभी आपको बताया कि एक कॉलम में आपको वो लेआउट देगा जिसमें एक कॉलम में आपका एक इंडिपेंडेंट फैक्टर, दूसरे कॉलम में दूसरा इंडिपेंडेंट फैक्टर और रिमेनिंग दो कॉलम में वो आपको रिस्पॉन्सेस के कॉलम देगा जो कि ब्लैंक होंगे। उन रिस्पॉन्सेस को फिल करने के लिए आपके जितने आपने रन्स बनाए हैं आप एक्सपेरिमेंटली उनको परफॉर्म करेंगे और उसके बाद जो रिस्पॉन्सेस आए हैं उन रिस्पॉन्सेस को आप उन कॉलम से फिल करेंगे। देन आप उसको इवेल्युएट करेंगे डिजाइन को एंड देन यू विल सी कि आपके जो इंडिपेंडेंट फैक्टर्स हैं वो कैसे इफेक्ट कर रहे हैं आपके डिपेंडेंट फैक्टर्स को। देन आप डाटा को एनालाइज करेंगे कि क्या वो जो एनालिसिस है वो राइट डायरेक्शन में जा रही है या नहीं जा रही है। इफ इट इज गोइंग इन राइट डायरेक्शन तो आप उन रिजल्ट्स को इंटरप्रेट करेंगे एंड देन आप उनको वेरीफाई करेंगे कि आपके जो प्रिडिक्टेड रिजल्ट आए हैं, क्योंकि लास्टली व्हेन यू परफॉर्म दिस एक्सपेरिमेंटेशन the factorial design or this design of experiment, it gives you a formula which is called as checkpoint batch. So वो checkpoint batch किस बेसिस पे सेलेक्ट आउट होता है कि आपने जो रिस्पॉन्सेस फिल किए और आपके जो इंडिपेंडेंट फैक्टर्स है उनकी जो कंसंट्रेशन है उन दोनों को अगर हम एनालाइज करें, यानी कि आपके इंडिपेंडेंट फैक्टर्स के इफेक्ट को हम एनालाइज करें डिपेंडेंट फैक्टर पे, तो वो किस तरीके से रिजल्ट्स को शो कर रहा है। तो लास्ट में डिपेंडिंग ऑन दिस एनालिसिस इट गिव्स अस वन चेक पॉइंट बैच। उस चेक पॉइंट बैच में हमें वो एक ऑप्टिमाइज्ड कंसंट्रेशन देगा इंडिपेंडेंट 1 की, एक ऑप्टिमाइज्ड वैल्यू देगा इंडिपेंडेंट 2 की एंड इट सजेस्ट अस कि अगर आप उन दोनों फैक्टर्स को इस पर्टिकुलर कंसंट्रेशन अमाउंट में यूज करेंगे और एक नया बैच फॉर्मुलेट करेंगे तो जब आप उसको इवेल्युएट करेंगे तो आपके रिस्पॉन्सेस ये होंगे। सो इट गिव्स अस रिस्पॉन्सेस ऑल्सो, राइट, एंड इट गिव्स अस डिजायरेबिलिटी ऑल्सो कि अगर योर एक्सपेरिमेंटेशन will be complying this formula then the desirability will be nearer to 1. So desirability means what we are desiring कि हमारा formulation का फॉर्मूला ऐसा हो, उसके अकॉर्डिंग वो डिजायरेबिलिटी सेट आउट होती है। सो मैक्सिमम डिजायरेबिलिटी वैल्यू इज 1। इट डिपेंड्स ऑन योर trials, your experimentation and एनालिसिस ऑफ योर एक्सपेरिमेंट, आपकी डिजायरेबिलिटी सेट आउट होती है। एक और चीज इसमें बीच में आती है कि यू हैव टू सेट आउट योर गोल्स। आपको एक और यहाँ पे फ्लेक्सिबिलिटी फैक्टोरियल डिजाइन देता है कि आपको अपने गोल सेट आउट करने हैं। गोल सेट आउट करने मतलब you have four types of variables with you. Two variables are independent variables, two variables are dependent variables. So आपको वहां पे select out करना है कि independent मान लीजिए हम ये रख रहे हैं डिसइंटीग्रेटिंग एजेंट की क्वांटिटी, उसका अमाउंट। सो वो जो हमारा वेरिएबल है हमें मिनिमम रखना है, मैक्सिमम रखना है, एक रेंज में रखना है कि हम ये चाहते हैं कि हाँ ये 5% से 10% की रेंज में यूज होना चाहिए। हम ये चाहते हैं कि ये हमारा नहीं, मिनिमम हमें क्वांटिटी रखनी है डिसइंटीग्रेटिंग एजेंट की, या हमें 10% मैक्सिमम क्वांटिटी रखनी है डिसइंटीग्रेटिंग एजेंट की, या एक और ऑप्शन ये हमें देता है कि हमें टारगेट करना है कि नहीं हमें तो उसकी क्वांटिटी 8% ही रखनी है। राइट, सो इट गिव्स अस फ्लेक्सिबिलिटी कि आप अपना गोल सेट आउट करो। अगेन फॉर दैट वी विल सेलेक्ट आउट वन गोल कि हमें इस पैरामीटर की क्वांटिटी इतनी रखनी है। सेकंड जो आपका इंडिपेंडेंट वेरिएबल है उसके लिए आपको वो फ्लेक्सिबिलिटी देगा, यू हैव टू कीप इट एज मिनिमम और मैक्सिमम और विद इन अ रेंज, और इट शुड बी टारगेटेड टू वन वैल्यू। ओके, ये दो पैरामीटर हमने सेलेक्ट आउट कर लिए। देन it will ask about the dependent factor. For example, I am taking disintegration time as a factor. So my goal with this experiment is the disintegration time should be least, means the tablet should take minimum time to get disintegrated if I am planning to formulate mouth dissolving tablet, right? Second thing, if I have chosen person friability as a second factor, then my criteria will be, what should I take? One, it should be less than 1% because we cannot go beyond that limit. This is the limitation. Yes, the person friability should not be more than 1%. So I have to choose that limit. Yes, my person friability of these tablets should be less than 1%. I can choose the target. Second, I can keep it, yes, it person friability should be minimum. Third criteria, I can also select out that it should be in the range between 0.1 to 0.8%, because I can keep in between this. Okay, now it will ask one more thing to me, that what weightage I want to give. Weightage means I want to give more weightage to my independent variables, or I want to give more weightage to my dependent variables. So because it will give me the formula on that basis only, what criteria I am setting out, what goal I am setting out, and what weightage I am giving to the parameters. So I can think, means my wish is to keep all the parameters at a same weightage. I will give the same weightage to all my parameters, both independent parameters as well as both dependent parameters, right? According to that only I want to analyze the effect of independent variables on the dependent one. So this, when it will give me the checkpoint batch, it will keep all my goals within the mind. According to that, it will give me the predicted results. Then my other next work is to formulate that batch and then again evaluate this batch with the given evaluation parameters which I have done for all my trials, right? And then see the variance of this new result with the result given by the factorial design. I will again compare this. If it is given to me that 5% of 10% disintegrating agent you use, super disintegrating agent you use, 5% subliming agent you use, then you will get the disintegration time of 20 seconds, right? And percent friability is 0.5%. So see, this result is according to my desirability. Now, when I will perform this experiment again with the given formula, then my result should be nearer to the responses given by the factorial design. If similar, I can not get, because we cannot, if I will repeat one experiment more than one time, then I will have the variable results, but the variables means there is variation in result is very less, because I am keeping all the experimental conditions similar every time, right? But again there is the changes in responses. That's why we go for the 3-time performance. We take n equal to 3 so that we can minimize the error between the experimentation. Okay, so this will be my last step, that we will compare the result of this optimized batch with the statistical result given by the factorial design. Okay, now, so central composite design, it is most commonly used. Fractional factorial design, where we can choose the number of factors and we can see the number of responses, uh, and we can see the effect of the individual factor as well as the combined factor on the responses, right? So this is the dashboard of the full factorial design. This is Design Expert 9.0. So when firstly you have to install this on your system, and this is run by Statis. This software is giving 15 days trial or 30 days trial. Initially it was 45 days, then they have reduced to 30 days. Now I think it is for 15 days only. So you can use that trial version for this experimentation. Then firstly you have to install it on your system. Then you will select out, you will click on this new design, then new window will open in front of you. So here what you have to select, you have to select out, firstly on left hand side you will see different type of design it is reflecting. Then you have to select the response surface, and in that you will find this central composite design. Then one window will be open over there, where on the upper margin you will see it is asking about the numerical or categorical factor. So if you have numerical factor, then you will select out that. If you have any categorical factor, then you will select out that also. So it will ask how many number of numerical factors you want for your experimentation, or if any categorical factor, then you can select one over there. Then it will ask you about the name of the factor. Below that you will find a table where you have to enter the name of the factor, right? So we have to write over amount of polymer, amount of disintegrating agent, amount of subliming agent, or this amount quantity of surfactant, whatever you want to select out. Then in front of that one more column is there, where you have to put the value of the unit. Means these factors are in milligram, these factors are in percentage, these factors are in microgram, whatever quantity, whatever units you are taking for this. Next column in front of this is the value of the factor. So here you have to select out, or you have to put the value, low value as well as high value, maximum value of that factor. It will ask about the low and high. Medium value it will select out by its own. Okay, if I am taking the disintegrating agent in between 5 to 10%, then in minimum I will put 5 and in maximum I will put 10. Okay, 7.5 it will take by its own. Second, uh, below this I will enter the value for the second independent factor. If I am taking it in between 0 to 5, then in minimum I will put 0 and in maximum I will put 5. So सबसे पहले हमने क्या किया, इंस्टॉल किया फैक्टोरियल डिजाइन को. फैक्टोरियल डिजाइन इंस्टॉल करने के बाद हमने उसमें न्यू डिजाइन को ओपन किया. न्यू डिजाइन ओपन करने के बाद हम रिस्पॉन्स सरफेस पे गए, जो कि आपको लेफ्ट हैंड साइड पे सारे डिजाइन आपको शो करेगा कि आपको कौन से डिजाइन को सेलेक्ट आउट करना है. हमने वहां से रिस्पॉन्स सरफेस को सेलेक्ट किया एंड इन दैट हम लोग सेलेक्ट करेंगे सेंट्रल कंपोजिट डिजाइन. देन वन विंडो विल बी ओपन, जहां पे वो आपसे पूछेगा कि आपके जो एक्सपेरिमेंट है उसमें न्यूमेरिकल फैक्टर है या कैटेगरियल फैक्टर है. आप दोनों फैक्टर्स को रख सकते हो, ये डिपेंड करेगा कि आपका ऑब्जेक्टिव क्या है. उसके अकॉर्डिंग आप इसको सेलेक्ट आउट करोगे. न्यूमेरिकल होगा तो आपको एक फैक्टर रखना है या दो फैक्टर रखने हैं, अकॉर्डिंग टू दैट आप सेलेक्ट आउट करेंगे. उसके बाद उसके नीचे एक टेबल दी होगी जिसमें आपको उन फैक्टर्स के नाम देने हैं, यूनिट देने हैं कि वो मिलीग्राम में, माइक्रोग्राम में, ग्राम में, परसेंटेज में, किस यूनिट में आप उन फैक्टर्स को लेना चाहते हैं. उसी के सामने एक कॉलम में आपको वहां उनकी मिनिमम वैल्यू और मैक्सिमम वैल्यू पुट करनी होगी, जिसमें कि आप ये ले रहे हैं कि मान लीजिए डिसइंटीग्रेटिंग एजेंट हम लेना चाहते हैं 5 से 10% की रेंज में, तो हम मिनिमम में 5 लिखेंगे, मैक्सिमम में 10 लिखेंगे. सेकेंड फैक्टर हम सब्लाइमिंग एजेंट लेना चाहते हैं, तो हम मान लीजिए उसको 0 से 5 मिनिमम टू मैक्सिमम हम सेलेक्ट आउट करना चाहते हैं, तो मिनिमम में 0 लिखेंगे और मैक्सिमम में 5 लिखेंगे. वहां पे हम कोडेड वैल्यू नहीं लेंगे. इसके फैक्टोरियल डिजाइन में कोडेड वैल्यू कैसे रहती है, -1 +1. -1 मीन्स मिनिमम, +1 मीन्स मैक्सिमम. और अगर हम ये जब हम 2 लेवल फैक्टोरियल को सेलेक्ट आउट करते हैं तो वो दो हमें ये देता है -1 और +1. अगर हम 3 लेवल वहां पे सेलेक्ट आउट करते हैं तो ये हमें देगा -1 0 +1. -1 मिनिमम, 0 मीडियम, +1 इज मैक्सिमम. सो उसके अकॉर्डिंग, लेकिन हम जो यहाँ पे फैक्टर्स की वैल्यू रख रहे हैं, यहाँ ये फैक्टर्स पहले हमसे पूछेगा इंडिपेंडेंट फैक्टर्स, राइट. तो वो जो हमसे फैक्टर पूछ रहा है वहां पे हमें -1 +1 नहीं लिखना है, हमें उसकी एक्चुअल वैल्यूज लिखनी है, right. Then one alpha column is there, we have to check out there should not be any minus value for this alpha, क्योंकि मान लीजिए हम सर्फेक्टेंट लेवल ले रहे हैं तो वो माइनस में नहीं हो सकता. हम किसी एक्सीपेंट की क्वांटिटी ले रहे हैं तो वो माइनस में नहीं हो सकती, इट शुड बी इन पॉजिटिव वैल्यू, right. So we have to check it out, there should not be any minus value. Then then by default it will take the rotatable alpha value. Okay, then next step is this alpha value, it determines the position of axial run, right. Then in rotatable 5 up to 5 factors we can select out. Standard error of prediction, it will have means when we will select out these 5 factors, then this standard error is similar for all these 5. Then we will select out face centered, right. So because in this each factor will be tested at 3 level, so 3 level we want to definitely check out what is at minimum level, medium level and maximum level, right. Then yes, face centered, it covers entire factor range, means minimum range, medium range and maximum range, so it is better to select out the face centered. Then we will select out the option, right, where we have the number of runs, it will show there the number of runs, minimum number of runs is 9. Then we will select out face centered design, then we can increase over there the number of runs, in this option. Okay, then the factor range will be automatically displayed in alpha column. So factor level, it will show over there minimum and maximum. Then we will click on continue. Then it will give us the table of responses. So it will ask us how many responses are there. So minimum we select out as one response, because definitely one response should be there, and we can go for many responses if we want to select it out. Okay, so this is the basic design. Then it is better to select out either 2 responses or 3 responses, not more than that. Then yes, recheck the responses, because once they are selected you cannot change the responses. You can change the amount of this independent factors, but dependent factors will be select out properly, because the responses should be selected which will be directly or indirectly affected by the independent factors. Okay, then if a correction is required, go for correction and then go click on finish. After selecting this finish, it will give you the design layout, which I told you just now, that on that design layout it will give you serial number, then it will give you number of trials, then it will show you the value of independent factor 1. It will show you in next column the value of independent factor 2. Then in next two columns, if you have selected 2 responses, it will give you the names of 2 dependent factors in next 2 columns. If you have selected one response, then in one column only it will give you the name of that dependent variable. Now you have to perform the experiment in the lab, and then you will give that detail in that box column, right? Yes. So here I am now discussing one example with you. 3/2 full factorial design was performed. 3/2 means 2 factors at 3 levels, right? For all their combinations. So here the independent factor was selected as super disintegrant, which was taken as cross povidone X. This its concentration was taken as 2, 3.5 and 5. So this is 2 is minimum, 5 is maximum, and second is subliming agent, which was selected as camphor, and its concentration was taken at 0, 5, 10. So in case of first, it is 2 and 5. Means minimum is 2 and maximum is 5, and in second case the minimum is 0 and maximum is 10, right? Then so factor A and factor B, they are called as, and then their responses, their effect were checked on the responses. So this is the coded value which I told you, that for factor A and factor B, these 9 combinations it have made. So these 9 combinations I have selected. This is the basic design, and number of run I have selected as 9, right? Face centered I have selected, and then this coded value is given the combination. So -1, 0, it means it is the minimum of factor A and medium of factor B, one combination. Then minimum of both the factors, second one, this minimum of factor 1 and maximum of factor 2, this is third combination. So likewise it will select out both, means all minimum with all maximum, all medium with all medium, all maximum with all maximum. Like this it will create the 9 trials, and this is the actual value of these independent variables, where for factor A we have taken from 2% to 5%. So 3.5 is the middle value, so it has taken. Second is for B factor, we have taken as 0 to 10. So minimum is 0 and maximum is 10. So according to that it makes the trials. Now next work was done. that these so this is an example of mouth dissolving tablets. So these tablets were formulated and then they are checked for the responses. So here two type of responses were taken in this study. One is disintegration time and second is percent friability. Because as I told you earlier that if I am going for the mouth dissolving type formulation, then its dt should be less, time should be less taken by the tablet to disintegrate, and second one is percent friability should be good, because when I am adding the super disintegrating agent, when I am adding an subliming agent in the formulation, then the as I told you that flexibility of the matrix will be increased, the tablet become more porous, then it is there is the chances that its percent friability will be increased. Okay, and we cannot comply with this higher value of percent friability because it should be less. The tablet should be enough strong to withhold or to withstand the wear and tear. Secondly, if this tablet is going for the coating, then in the coater the tablet will be converted into the powder if it has not passed through the percent friability test. Okay, so that's why it is very much necessary. So that's why I have chosen these two parameters as the dependent parameters, because these responses will be directly affected by the change in the concentration of the independent factors. So this is the polynomial equation. Y is your response, and again A is your one factor, B is second factor, then AB. Look here, AB is there combined when they are joined each other, and again there is a square and b square, means 2 times of the value of a factor and 2 times the value of b factor. According to that, the both polynomial equations are here. See here, p value is also given, and this is the coefficient value which is given in x coefficient, and this is the value when full factorial mode is there. So if we talk about the p value, then in first case for disintegration time it is very less, right? Again for b factor it is very less. But if we see when they are combined, then it is more than 0.05. Again, if I am taking the square of factor a, it is approaching to 1, which is not desirable. Then if I will take b square, I am increasing the quantity of second factor. Again, we are in the range. Similarly, if I will check out for percent friability, then it is good for A factor, good for B factor, again for AB also, means here all the p values are in the range in case of percent friability. It means the experimental results are in compliance with the statistical results, which is done by this software by using ANOVA. So our experimental results are in compliance with the ANOVA results given by the factorial design. So after analyzing this, the factorial design has given us this predicted formula which is given below. So according to its analysis, it is giving factor A as 10 milligram, factor B as 20 milligram, because I have set out here the goal as minimum disintegration time and minimum percent friability. So according to my goal, it has given me this formula. Yes, factor A should be taken as 10 milligram, factor B should be taken as 20 milligram if I want the desirability as 1 and dt as minimum and percent friability in the range. So 0.5 is okay because we are not crossing to 1, as well as its value is not too less because we are adding the super disintegrant as well as subliming agent in the tablet. So definitely the tablet will be porous, right? So that's why its value of 0.591 is up to the mark. Here I want to tell one more point. Maybe this predicted solution, it lie in between the 9 trials. Means whatever responses you are keeping in the table and what criteria you are setting out, what goal you are setting out, according to this the factorial design can give you one formula which is among the 9 formulations which you have prepared. So if the case is like this, then you can say yes, this batch is considered as optimized batch because this formula is given by the factorial design and the our experimental design are consistent with the factorial design results, we can say. But second case may be like that, it will not give any formula which is similar of any of the 9 trials. It can give you a new formula. Okay, so here in that case, in actually in both the cases you have to go for again the formulation of this new batch, because we have to check out when we are performing this, when we are formulating a new batch using this new formula, our evaluation results are consistent with the statistical results or not, right? So if it is a batch from the 9 trials, again we will formulate it and then we will evaluate it and we will they compare the results and then we will see the p value, it is complying it with or not. We will see the coefficient, means how the results of the experimental design, they are complying with the statistical design or not. Okay, again if it is a new formula, then definitely we have to go for the formulation of this batch and the evaluation of this batch, and then again we will compare the experimental results with the statistical results. So this is the last point, this is the last step of our whole experimentation, that the results of the evaluation of optimized batch should be compared with the statistical results. Clear? Then if we will in compliance with it, it means our experiment is up to the mark. But if the results are variable, then the statistical results, it means your experiment which you did at the time of trials, it is differing, your responses are not appropriate, which whose value you have put down in the response column, and that's why your optimized batch results are varying from the statistical results. Clear? So these are the response surface graph. Here first 3 are the contour graph where it is showing, you can see over here one factor cross povidone, it is here percent and this camphor is here. So it is showing the effect of these responses on the disintegration time. So as this center point is here and axial points are here, so it is going from red region to blue region where the value of this is increasing, means quantity of these two independent factors is increasing, and if it will be increased, then the dt value will be increased, right? So means it when we are taking it in lesser quantity, then dt time will be more. And when we are taking more quantity of independent factor, then disintegration time will be less, because it will affect uh, negatively, right? If we check out the friability, then when we increase the amount, then percent friability value will be reduced. Again, it is showing the negative effect on this. If we are taking lesser quantity of camphor and cross povidone, because their lesser quantity will make the less porous tablet. So, sorry, in that case, the percent friability will be more, right? Third graph will be showing the desirability. So if we take the 110 milligram of this and 20 milligram of the camphor, then we will get the formula whose desirability will be 1. So if in this case the F9 batch was having the similar composition which was given by the factorial design. So after that, what is the next step? Next step is the formulation of that batch and then evaluation of that batch, and again we will compare the results of experiment with the statistical results. Then we will see that similar responses we are getting or not, right? Third graph is your 3D graph. It is showing again the desirability graph, where it is showing the amount of this cross povidone and camphor, which is here. That point is showing its concentration of both of these independent variables, and responses are on the desirability nearer to 1, it is showing, right? So this is the 3D graph. So in this case, the A and B factors significantly affected dt negatively, as I told you, because where if we increase the amount of the super disintegrant as well as subliming agent, then disintegration time will be reduced, right? Again, if we check out for the second factor, then the percent friability will be increasing. So if the factor will be increasing, then percent friability will be increasing. If it is decreasing, then percent friability value will be decreasing, right? So if we check out their combined effect, then it is showing the significant positive effect, and p value is within the range which is less than 0.05. Okay, so it was all about the factorial design. Here we discuss about the central composite design. So I will come with the other designs very soon. Till then, bye and thank you very much.
Thank you so much, ma'am. I wanted to extend my heartfelt gratitude for the exceptional webinar you delivered on the design of experiment. Your expertise and passion for the subject were truly evident throughout the session. Your insights into the topic were particularly enlightening and have left a lasting impact on all of us who are watching you on live session. Thank you so much, ma'am. The clarity and depth of your presentation made complex concepts easily understandable. We gained a wealth of knowledge from your webinar, and I am certain that everyone in attendance found immense value in your expertise. Your commitment to empowering others through education is commendable and deeply appreciated. Thank you once again for sharing your time, wisdom, and insight with us. Your contribution has been invaluable, and we are looking forward to applying the knowledge gained from your webinar in my endeavors. Wishing you continued success in all your future endeavors. Thank you so much, ma'am. And one message for our attendees, please fill the feedback form to get the certificate mentioned in the comment section. Thank you to all of you to join us and support us. I am signing out from here today. Thank you so much.